So I'm going to move this over here. And again, this is still dimethyl cyclohexene. But now the number system goes and say we make this 1, 1, 2, 3, 4, 1, 2, 3, 4, or we make this 1, 1, 2, 3, 4, or 1, 2, 3, 4. No matter what I do, this is going to be a combination of 1 and 4. Dimethyl cyclohexene. And this is how we name these compounds. So if we have 3 or 4 attachments, you have to go in the order that gives you the lowest sum of attachments. There has to be a 1 in there as well. Okay? Now, let's take a look at cyclohexenes. Now, first of all, let's talk about hexene. There was a point in any hexene where, and we talked about this in the last lesson, that every angle here is 120 degrees, and this is completely planar. Okay, now let's suppose I put. I'm just going to do this a little different. I'm going to put a red here. And I'm going to put a green here. Now, everything else beyond it, there's more carbons attached to it, like the red and green here. It's going to go off and on at 109.5 degrees. This is the only area where everything is planar. These 6 atoms all lie in the same plane. Okay? Now, I have a structure here, where I have a cyclopentene. And as you can see, the structure here is planar. This carbon, this carbon, this carbon, this carbon, and this double bond all lie in the same plane. But these things out here are sprouting out at 109.5 degrees. That's what's going on right here. We got these attachments here. I've got this right here. The red part is over here. The green part is over here. And we have attachments here, be carbons or hydrogens, whatever. Okay? Now, we could have put the green over here. Whatever the green structure is right here, methyl group, alpha group, whatever. And I'll put the red group over here, methyl group, alpha group, whatever. This is a geometrically different compound. It is the same group of atoms, C2H2 red green, C2H2 red green. Okay, it's the same collection of atoms or stuff, if you will, but arranged differently. And they must have different names. Now, we're not going to get into that, but I'm going to explain to you that this is a thing that does make a difference. This is called a cis configuration. This is called a trans configuration. The prefix trans means across, like there's the Trans-American Highway, where it's going from Alaska all the way down to somewhere in Central America. It's called the Trans-American Highway. It's going across America. This is going across the compound. This is a trans compound. This is a cis compound. When we talk about cycloalkenes, it is difficult to get these things to wrap back around and bond together. So this only exists in large carbon cycloalkenes, but all cycloalkenes will fit in a cis fashion. So we're never going to have to worry about that. We're not going to worry about the names later on. I'm doing this for two reasons. One, you're going to see this in organic chemistry if you take it. I'll just give you a tad of a heads up on that. The other classical people have encountered this in the past, and so hopefully they'll understand if they get across this. All right, so this is what we're basically going to be looking at. And in this compound right here, you can see that the plane that we have here, that the two attachments of the cycloalkene are on the same side of the carbon, so this is a cis structure. And I think the first time a cis structure is actually seen in cycloalkenes is at, I'm going to say it's the 7th. Cycloheptene can't be found in terms. So let's just move on from there, and let's just get the names for these things figured out. Now this double bond is going to have an effect on the names. Okay? So let's take a look at this compound right here. And we draw the double bond right here. You draw it anywhere. I'm putting it on the bottom because that's where I have it right here. You can see the shadow back here. Beautiful broken marble. Now, this is called cyclopentene. There's no number because it's going to be carbons number 1 and number 2 no matter what. Remember, in alkenes, the double bond gets the preference of the lowest numbers. So if I were to put a methyl group on here, let me draw a penny on this side. This is so hard. And now I'm going to put a methyl group not on the double bond. Okay? Now, again, double bonds get the priority of the lowest numbers. So that means it's going to be 1 and 2 here or 1 and 2 here. Then the methyl group forces the direction that will give the lowest possible number. So if we go 1, 2, 3, 4, 5, this would be 5 cyclopentene, or 5 methyl cyclopentene. Or if we go this direction here, 1, 2, 3, and remember 1 and 2 must be included in the bond, double bond. And this becomes 3 methyl cyclopentene. And that's going to be the preferred number because 3 is smaller than 5. And notice you don't put a 1, 2, or anything like that for the alkene or the double bond. It is implied that it's always going to be those 2 numbers. So this is 3-methyl cyclopentene. All right, I will do one more. And for this, I'm going to put it right here. So the question comes into play here. What numbers do we attach to that methyl group? Well, it being on the double bond, it's going to be on either carbon number 1 or carbon number 2. Well, obviously it's going to be carbon number 1 because that's lower than number 2. So this is going to be known as 1-methyl cyclopentene. There will never be just a plain 2-methyl cyclopentene because if we move this over here, that now becomes the number 1 carbon, so we'll never see that as an option for a 1-methyl group being on there. Now, let's put a second methyl group on there. And let's put the methyl group there. And then let's put the methyl group here. Now this is a dimethyl Cycloalkane. The question is, what are the numbers in front? So, let's suppose that we make this carbon number 1. It's either 1 or 2, we already know it has to be number 1. So the question then is, and why is it 1 or 2? Because the double bond has to be 1 or 2. Okay? So before you get confused by that. There's 2 directions we can go in this. We can go 2, 3, 4, 5. Or 1, 2. No, we can't make that 2, can we? Because the 2 has to be right there on the double bond. So that's our only option there. Okay? So that means then that we can make this 2, because there's 1 here, then it can also be 2 here, because this has to be either 1 or 2. These 2 carbons. So that means that would make that carbon number 1, and that would make that carbon number 3. So here are your 2 options. Our 2 options are 1,5-dimethylcyclopentene or 2,3-dimethylcyclopentene. Which one works? Well, this is where the sum comes into play. What's 1 plus 5? 6. What's 2 plus 3? 5. That means this is the correct answer. So this is not going to work. So this is going to become 2,3-dimethylcyclopentene. And that's how cycloalkanes and cycloalkenes work. Like I said, there's no such thing as a cycloalkane. Your practice problems will be on a PDF form, attaching the PDF form, or along with the PDF form of this Smartboard stuff. All right? Have fun.